Hello, everybody. My name is Rainer Michaeli. I'm the director of the Institute for Competitive Intelligence, and it's my pleasure to host this very webinar session. Today, we have a speaker, Nelson Silva, from the Node Center in Austria, which is hopefully a very interesting opportunity for you as well as for me to meet him, well, not in person, but at least somehow virtually. Nelson, are you in our line?
Hi, hello, good afternoon to everyone.
Yeah, so I'm always keen to check the audio connection with my speaker, so here we have no problem though. Yeah, automated intelligence and supply chain risk analysis using NLP. Well, that's not only a long title, it's a very sexy title. So I guess we're all looking forward to hear some interesting stuff from you, Nelson. I suggest you make a quick introduction. Next slide will prepare a bit of your CV. And then the floor is all yours. We have some 20-25 minutes. And obviously then we can take questions. To take these questions, please use your chat window. As you can see in your GoToMeeting frame, there's a bit of a box. And in this chat window, you can simply type and then return button so we can see what you send to us. I will read out these questions later on, and then Nelson can comment and hopefully answer all your requests. Yeah, Nelson, I guess now it's all yours. Please, go ahead.
Thank you, Ben. So good afternoon. My name is Nelson Silva. I'm the head for strategic intelligence at Node Center. I will tell you a bit more about Node Center in the following slides. But first, just a quick overview of the topics for today. So we will discuss about what is for us supply chain intelligence and why do we need this supply chain intelligence. I will show you a very short case study about the analysis of TRN supply chain. And I will also discuss a bit about automation of information, NLP, and finally, we will conclude with some key takeaways for this session. So, Node Center. Node Center is a research center based in Austria. Is the leading research center for data-driven businesses and big data analytics. We have more than 100 dedicated experts in data science, so data scientists by training. Among them, there are some PhD students, master students, professors leading several departments. And our mission is to support companies in all topics related with data-driven business. So I would like to start by introducing you to, let's say, one of our topics or one of our, let's say, buzzwords that we like to introduce. That is the topic of assistive intelligence. So usually we receive requests from companies through our business development teams. And we forward these projects then to our internal areas or internal research areas, such as knowledge visualization, knowledge discovery, data management, and so on. And for us, these projects have a big component of data analytics, where we have to extract and analyze big quantities of data we use advanced algorithms for these analysis, and we need, of course, a lot of computing power. And also, one of the main goals is, of course, to support the workforce. And that's why we like this term, assistive intelligence. So, to have intelligence overview, and what do we mean with this? So, there is a lot of information available internally and externally, and one main question is, can we trust this information? Also, which parts of this collection and handling of information can we automate? So for that, we need to identify work processes. We need to support these work processes. We need to introduce sometimes new systems or new tools to support the workforce. So one of these components is, of course, the crawling of large amounts of data. These data can be textual data, but not only. And we support companies not only in the setup of these systems to collect and extract data, but also then on the analytics part, on the development of new algorithms, on the study or on the report about the state of the art for these analytics processes, methods. Well, one of the components that we will discuss today is the automation of a small part of the supply chain. So, as you know, as you probably are aware, there is a lot of information available internally and externally out of my company and inside my company. And one connection here to the topic of competitive intelligence is this term VUCA. So we know that markets are volatile. There is uncertainty in the information that we get and that we can use. There is complexity in getting insights from the information that we collect. So we need to improve our knowledge extraction capabilities. And all of these only makes sense if we can somehow create assistive intelligence, meaning with that we can support decision makers and we can support the workforce. In these slides, I have a very, let's say, generic view of what we are talking about when we talk about these intelligent architectures or systems. Well, you can imagine that a company might have many systems already in place, such as SharePoint or other systems, ERP systems, PLM systems. And however, usually there are some difficulties in extracting real knowledge from or interconnecting all these systems. And that's where also KnowCenter can help because we work across the different needs. We create tools and algorithms to analyze these data and even to integrate the data. So if we think on a set of systems or tools or algorithms that we can place on top of our existing architecture, is, for example, the need to crawl information from documents that exist inside the company or outside the company, such as Office documents, PDF documents. We might also have the need to extract information from websites, from blogs, from forums. And it would be nice to have a user interface that allows us to search through this information. And that would be this block number 1 on the left side, on the bottom left side. Also, of course, we could do some of these investigation of information using Google. However, Google usually doesn't return the search results in a way that is according to our business view. That's why we need to define the taxonomies, and we need to define how the information should be consumed internally. Also, throughout the years, information is stored, but it was always very difficult to classify this information and to annotate this information. And for that, we sometimes need to create automatic services that handle this part for us. After that, and after we created algorithms to analyze the data and to extract knowledge from the data, we need to visualize, we need to support decision makers. And for that, we usually recur to BI services, business intelligence services. But as you will see on the next slides, there is a slight difference between BI service and advanced visual analytics, for example. Then we would like also to support the workforce, and that's why we might need to create additional tools that support the workforce. For example, we can support the workforce with intelligent interfaces like chatbots, or using HoloLens for augmented reality or mixed reality. Or we can, for example, create interfaces that integrate themselves into Office or into Google Docs, for example, to support contextual writing support. Meaning that, for example, if you need to create a proposal, then you might have an intelligence user interface that supports you in the writing of these proposals. Okay, like I said, so there is let's say a big slight difference between the standard BI services and advanced analytics. When we are talking about system analytics and advanced visual analytics, we assume that we are applying advanced algorithms, deep learning algorithms, machine learning algorithms, to analyze the data and to allow a much improved interactive exploration of the data. And these interfaces can be applied to analysis of documents, analysis of KPIs, or it can be used by the workforce during during maintenance of machines and so on. But we need to integrate all these systems in order to have the maximum, to extract the maximum potential of these assistive intelligence. So now we will enter the case study for today, where we will discuss a bit about supply chain intelligence and why do we need this supply chain intelligence. So the world is changing fast and constantly changing, and there are partnerships between companies that are made, and lots of relationships. These relationships change with time, and companies can be acquired, can be merged with other companies. So also unexpected disruptions like strikes, earthquakes, and so on can happen, and they can have a big impact on the supply chain. Therefore, it's very difficult to predict the real impact of these disruptions, and it makes sense that we could create automated systems to regularly crawl or extract information from online sources, for example, to create a current map of these relationships between suppliers. So the main topic here is the collection and analysis and distribution of this information that we can extract from open sources, for example. So let's imagine that we have a buyer here in São Paulo, for example, and this buyer has several suppliers across the world. It might have a main supplier in Luanda, and for example, this supplier in Luanda might have another sub-supplier, so in a second level, that is providing a component or a service to Luanda, but this service, of course, has an impact on the buyer. But what we are seeing here is that these relationships can be many and can be more complex than what is displayed now on the screen, because we will not have only tier 1, tier 2, tier 3 relationships. We will have much more deeper relationships, and small suppliers, for example, might also be supplying some type of service or some component, some product, and we might not have full visibility of what are the companies involved into this process. Another topic that I discussed a bit before is that, well, there are so many systems and so many relations inside and outside of the company that we need to handle to be able to extract knowledge from the data that we are storing, that the entire architecture becomes very complex. So we might need to extract information from the web, extract information from documents. We need to set up our BI services so that my workforce and the decision makers can have a self-service entry point to the data. We might need to run simulations. We might need to do forecasts. So there are a lot of things to do and to integrate. Okay, so it would be nice to develop tools that can extract information from open sources available on the web, and with a certain accuracy, it would be very valuable if these systems can do this task of extraction of data automatically, because it's very difficult to keep this overview of how the relationships between suppliers and between different companies evolve through time. So if we would rely on our salespeople, marketing people, and so on to keep up with all the changes, this becomes very tough, very difficult. So we would like to know how much can we rely on the automatic extraction of information from open sources. What are the benefits of doing this? Well, maybe we can identify top-end production sites. Maybe we can identify single points of failure, meaning which suppliers or which companies can affect the entire supply chain if they fail, if they get disrupted. It would be also very valuable if we can somehow keep an eye on acquisitions, takeovers, demand shifts, outbreaks, and shortages risks. So I will quickly switch to the demonstration, quick demonstration. So maybe Rainer, can you just tell me that you are already seeing the demonstration?
Yep, that's on very well.
Okay, thank you. So this overview of the supply chain that I have now on screen was completely created by automatic extraction of data from open sources on the web. I cannot tell you all the details that were used for the creation of this network, but you quickly realize that it's complex. It's a lot of data points. Each data point is a company. And there are lots of relationships. You also see different colors. These different colors, to keep it simple for this example, I will just tell you that they are companies from a certain industry sector. So meaning that, for example, blue might be metal industries, or pink might be, I don't know, plastics, and so on. And if we zoom in, so we cannot see much yet. We just see lots of companies, lots of industry sectors, and lots of relationships. So let me just, for example, filter by one of these groups. So you can see now that we are only analyzing one type of industry sector, for example, and there are lots of companies collaborating with each other and taking certain analysis metrics. We can then compute how these relationships are working right now. How can we do that? Well, it might be because these companies are simply referring to each other. It might be because we also integrated information that was brought in by our sales team or marketing team. It might be that we are analyzing news articles or magazines and publicity, for example. But what we try to understand is how these relationships might look like from different angles, from different perspectives, metrics. So here we have one of these perspectives where we see these relationships, and we see that there is a big concentration of companies collaborating with each other here in this more complex cloud. And one thing that we also discovered, for example, in this example, is that there is a company that is responsible for, it's the main responsible for all the activity between not only one industry sector, but between many industry sectors. Meaning that if this company would have a problem or could be acquired by one of my competitors, for example, it might result in problems for my supply chain. And these are the kind of things that we want to discover from the analysis of, in this case, from text sources. What we can do then is, of course, if we have already an internal view of how the supply chain is working, I might be able to compute a confidence level on what my algorithms are doing automatically by extracting information from open sources versus the information that I already know internally and how good it is. Can I compute it like this? How much can I rely on this mapping?
Nelson,
yeah.
There was one question for you regarding this chart and I guess the whole session. Can you tell us which tools you are using to automate the collection of open source information?
Yes. Well, let's say for the technical audience, if this question comes from a more technical audience, I would say that we use all the standard tools that are available, so libraries for extraction of text and so on. However, we develop our own crawlers. We develop our own systems to do this collection and this extraction. So we don't rely on a, let's say, commercial tool. We develop our own tools. And these tools might have in-house developed algorithms, or they might rely on also open source libraries, for example. Maybe this answers the question?
Would be good if you could name some commercial tools or simply refer to it as in, well, it's a bit like a Google indexing tools that downloads, extract some information. Or are we talking about a full text database that you locally build? Yes,
we build this. We feed this local database by identifying which data sources are relevant and are possible to be crawled. And then we start a crawling process that can take 1 day, can take 1 hour, or can take several months. We also recrawl these data sources. We also extract again information regularly, information from these data sources when it's needed, depending on the type of task that we are performing. Well, I can tell you names of libraries or things like that that are useful. I mean, the usual suspects are always useful. You can use libraries like Spacey or Open NLP or whatever. However, this is not enough. So we need to develop our own algorithms, customize what we are doing to the needs of the company, of our customers, of our partners, right?
Here's another question. I think we take it right now and not wait until the end because it seems to be very interesting. You mentioned M&A as a potential development. What are indicators that you would extract to identify sort of ongoing or prevailing M&A activities? Obviously, before it's in the press, so how do you know before somebody published an M&A article?
Yeah, well, let me say this. What you are seeing on screen now, it's a very simplistic demonstration that is more the end result of the analysis than the beginning, okay? So, of course, we have to rely on inputs from the sales team, from the marketing team, from the decision makers. We have to rely also in the inputs that frequently these sales teams and marketing teams bring to the company about what they heard, about what they discussed with other decision makers, for example. But imagine that, for example, we are analyzing the last 2 years of magazine publications. So there is important information that we can figure out from these articles being published. One question that I receive frequently is, what about fake news? What about non-reliable information, right? So it's all about of cross-checking different sources of information directly from humans and from machines, right? So metrics that we can use are, for example, let's say the number of articles or publicity published by one supplier, cross references between suppliers, investments made by suppliers, for example, by partners or by companies or by competitors, right? So if we follow these news, then we can start creating a picture of what is happening. And you can do this by reading all the articles or by searching the information yourself, or you can start relying on these automated extraction tools that gather the information for you with your business view, organized with your business view. And then, of course, you still need internal discussions. You still need a team, maybe a competitive intelligence team that looks at this data, but already treated, already analyzed. Maybe if you are creating a graph like this, then you will compute some graph measures on top of the information. And you use visual analytics tools to explore the information. But the human factor is still a big play. I think nothing can replace that still. What you can do is to automate the collection of data, to automate the checking of facts, and so on.
Okay, fair enough. This definitely answers the questions. Please just continue.
Okay, so let me just close my chat window. Okay, perfect. So I think you can see already again the slides, right?
Yeah, we're back to your presentation.
Oh, okay. So how to make this data or this knowledge extraction. If we think a bit more on the technical side or scientific side of data analytics, you can do many things. So you can think on the basic part, where we manually annotate information, we identify data sources, we identify competitors, we identify suppliers, we identify other players, and we start with this. There is a next level where you start creating, for example, classification models. These classification models usually require some rule-based definition, or they require annotated data. So using certain types of annotated data, we can start classifying new information that we are extracting. And we can start putting this information in the right container, let's say. So I can, from a list, for example, of companies, I can start having a clear picture of where are my competitors, where are my partners, what are my main customers, suppliers, and so on. And from there, I can start drilling down. I can start extracting more information about everything that relates with this company. One problem that usually occurs is the language problem. So when we are trying to analyze textual data, we need to handle different languages. At Knowcenter, we are very focused on the English and German language, but we also handle other languages. One difficult language, for example, is Croatian. So we, throughout the time, we developed language models. We trained algorithms in specific types of documents that allow us then to extract information from texts that are similar to the ones that we trained the model for. I don't know if this makes sense to the audience, but when we are trying to create a model for language understanding, one possible step is the training of an algorithm on existent documents that are already annotated and they are already classified. Meaning that if you have a big set of business documents for a certain topic, for example, and you train your algorithm, and you annotated these documents prior to the training, then this new algorithm, this new model, will be able to extract useful information. For example, we might be able to automatically extract or identify when there is a name of a company, a name of a person. So there is an example on screen. For example, you might imagine the sentence, on 1st of January 2018, Miss X was announced as the new CFO at ACME. So we can, for example, using NLP and in this case, a name entity recognition, we could identify that there is a date, there is a timestamp, there is a person, there is a role, and there is a company. Of course, for the technical audience, you will be thinking already, well, usually sentences are not that nice, that clear. And the facts might be far away from each other on the text. So We might start with a sentence that tells something useful, and in the middle of the text, we will find another missing factor, right? So the identification of entities is not enough. We also need to be able to contextualize the information that we are extracting. So is Miss X really the CFO? So you might be able to check this in the current text, or you might need to cross-check this information later, to confirm this information later with other information that is being extracted from somewhere else. Okay. So let me try to advance the slides. Yeah. So, of course, throughout the years, No Center developed algorithms and frameworks to extract this information from documents and from online sources. You are seeing just a small example of such framework, such system, where on the left side you can see how the information is being aggregated. We are identifying which persons are being discussed in the texts. We can see how often they are discussed. We might be able to do sentiment analysis, for example, or tonality analysis. We might be able to identify locations automatically. We might be able to identify the creators of the article and relate the creators of the article, for example, with regions, with the persons being discussed, with the companies being discussed. And I will not show you this in this presentation, but we also do trend analysis, for example, where we analyze the topics being discussed, the evolution of these topics, the evolution of referencing certain persons, certain companies, and the overall evolution of relationship between companies and persons, for example. We recently integrated a knowledge graph into our framework, where we not only integrate all the other things that I presented before, but we also work on the automatic inference of relationships from sentences, for example. So we are constantly trying to improve our way of mapping relationships and our way of detecting automatically these relationships between entities, between persons, organizations, products, and so on, so that we can improve the accuracy of our network mapping. And for that, we created a new interactive graph framework, exactly to allow the decision makers to explore better this information. Of course, this is not the end of the story. So this graph networking is just one part of the story. So we need to integrate different sources of information. We need to develop models. We need to do forecasts. We need to create simulations of what could be, so that we can predict or anticipate what we can do. And this is not done just at the level of competitive intelligence, but also on other levels. For example, on the management of production processes, on the buying of goods, and so on and so on. So it's of course a complex. There are complex scenarios. This is not a straightforward thing to do. But once you can extract reliable information and integrate it, then the outcome is very, very positive. I would like to highlight some key takeaways. I try to put it in a way that doesn't make sense only in terms of complex supply chain analysis, but also overall in terms of knowledge extraction and information analysis. So always one key factor is the inclusion of the human factor. So companies need to automate processes. They need to map these processes in some form. Optimally, they should use tools that allow to automate these workflows, maybe using business process mapping, or including execution frameworks that can automate these workflows of information exchange between persons and machines. And if we can automate these workflows, we can start creating support tools for the workforce, and we can integrate the information that is being automatically extracted from different sources into these workflows for approval, for cross-checking, and also, for example, for the creation of predictive models. So the mapping of relationships and information facts can be done automatically with a certain degree of confidence and error. Needs to be checked, of course, and needs to be constantly monitored. It brings definitely many advantages, starting that you don't have to solely rely on human intelligence gathering, and you can plan for future problems. And the main message that I would like to pass is that knowledge can indeed be integrated. So maybe there are more questions now, but I will end my presentation now.
Yeah. So thank you very much. Please use your chat function to send more questions, and I will read them out. Here's the first one. Can you tell if the update of the GPhi network graph is automated?
So I'm not sure exactly what is the question.
Okay.
I can imagine that yes, we can in real time even update a GPhi network graph.
Maybe you just show an example of the slide, so not everybody might be familiar, just as himself, what a GPhi graph is.
Well, I don't have one now here. I'm
Oh,
really
I thought in your
no,
presentation you had one.
Gephi is another tool. So what we saw on the slides is not Gephi. It's a tool developed by us. We know Gephi, of course. It's one of the tools that we study when we are students, and we used it, of course. It's a very good tool. But Gephi is, let's say, one of the small analysis parts that you can use, where you compute, for example, the importance of a relationship in the graph and so on. So, but yes, the answer would be yeah, we can automate also the network graph in Gephi. Yes.
Okay, so here's another question. How to detect earthquakes? This refers to page 10 if you just want to flip back. Supply chain intelligence.
Yeah,
obviously, I think the background of this question is very much there's typically no news prior to an earthquake, but you're relying pretty much on published information. So how do you make this happen?
Yeah, well, you don't. Well, the slide is not referring to the prediction of earthquakes, but to the prevention of disruptions in the supply chain that are that origin from an earthquake, for example. So I remember a famous case in Japan when there was the Fukushima disaster. That one unknown supplier for a famous automotive company in Germany failed, because the production was disrupted due to the earthquake and to the nuclear disaster. And for 6 months, this company could not deliver one of the models of cars because a very small plastic component could not be replaced and could not be approved anymore. So in that sense, we are not doing the job of the earthquake detectors. We are more preparing and planning the future of our supply chain.
Okay. Fair enough. I guess a good question. So, can you give an example for advanced visual analytics?
Well, maybe I can just let me see if I have.
I think there's a bit of an application here. So, where do you use it? What kind of environment would be good for that? Because obviously, if you're talking about millions of data points, there's not much use in visualization just to see more points.
Exactly. That's why when you try to load your data sets with these millions of data points to tools like Tableau or so, if you don't apply advanced analytics and, let's say, machine learning algorithms to cluster the data, to aggregate the data, to compute relationships in the data, then it's just a standard BI dashboard, a direct map from data points to the screen. And this would be too much information and not valuable information. So what I mean with advanced analytics is exactly the other way around. So we need, on top of these millions of data points, we need to apply machine learning and models to make sense out of the data, but still we need to visualize it. But we will not visualize the millions of data points, but the already treated, analyzed data using these visual analytics methods.
Okay, so my question on top of that, if you go for patent analysis, say of a competitor or a whole group, an industry that might impact later on you, say as an OEM, how would you know what to analyze and what not when it comes to patents. So how would you sort of predict emergence, breakthrough, discontinuity technologies based on patents, based on company information?
Well, you are of course many times very much relying on the correct identification of data sources. And these data sources are constantly changing and must be, let's say, cross-checked, verified somehow. But of course, once you gather enough information from reliable data sources, or you can verify this reliability, then you can create prediction models. You can forecast what might happen. So that would be my answer for now. The identification of patterns has a lot to do in that sense, in the sense of identifying when the technology will be mature enough or will disappear, or so you have to rely on a lot of cross-checking between data sources.
Okay. Then there's a question about tools, software tools, I guess. Which ones are proprietary, i.e. Your tools, and which one are commercially available? Can you comment a little bit on, I guess the question is sort of how could somebody from the audience in a company, rather than a research institute, which you of course have, how could you try to mimic such a process? Or analyze similar supply chain as in your example? Risks.
Well,
your recommendation?
Yes. Well, of course, the first answer would be, come to us, work with our research institute. We are not a software vendor, so we are very happy to work on specific problems and to work on the creation of models to tackle your current issues. Of course, there are some commercial tools, either from the competitive intelligence side or from the big data analysis, let's say. I can say names. So there are many people using SAS. There are many people using Google Analytics. There are many people using other things. But it's not about the tool. It's about the insights that you can extract, and also the processes that you set up in the company to share information and to confirm information, and to automate this approval and sharing of knowledge.
Okay, so here's another question for you. This tool helps to identify risks. How do you quantify the impact?
Well, it depends on what we could extract and on the model that we created. So if we are talking about a model that is predicting the probability of something happening, then that is what the algorithm will do. The algorithm or the model will be trained on data, and it will give you a confidence level of occurrence or some other factor. That's it. To quantify risks, it's not a straightforward process, I guess. So, but many companies worked for a long time in their own formulas for this computation, for example. and we will include it in the model.
Okay. And I think you mentioned several times throughout your presentation, you still have some human beings in the loop who might take on this very job of quantifying impacts once they're aware of it.
Maybe not of quantifying, but of contributing to the quantification, let's say. So people might have to, if we are talking about a specific example of my sales team that is going to different conferences, shows, doing business with several entities. So these people will, of course, collect relevant information. They are kind of the spies of my organization. But this information can always be biased. But once you put all this information together in a pool of data, together with data automatically extracted, and you start looking for patterns, like you said, and quantifying things, you will anyhow need some kind of approval processes and investigation process where people will confirm, disconfirm, will say, well, this is important, this is not important. But much of this work is now being replaced by the algorithms, because the algorithms can give you can be, we hope they can be less biased than people. At least we try to work in that direction. And one of the trends is, of course, to not only create models and algorithms, but also to work on the explainability of these algorithms.
Okay. Yeah, final question. I'm afraid then we have to really finish our session. How to become a data scientist by training?
I would say that this is like a lifelong learning because you will need to well, there are different levels of data scientists and data analysts and so on. And this requires a lot of time. So it's a long process. You need much knowledge. You need to do training courses. You need probably to invest in your education through a master degree, for example, that is focused on data science. Yeah, it's.
So I think the question.
So my answer to that is I'm very afraid when someone labels himself as a data scientist.
but again, I think the question is pretty much: is it an academic master, bachelor job, or is it more like a certification which you do while you're on the job, but with a different initial?
Well, yes, of course.
Mm-hmm. So what would you recommend? You mentioned in one of your initial statements that no center has a lot of data scientists. Mm-hmm. So I guess this was the initial idea. So how do you become one? Or if you're not one by now, how will you get one?
Well, of course, it depends on your starting level. So there are many people that don't consider themselves data scientists, and they are already data scientists. But the field is evolving so fast that you need to keep up with the research every day, every hour. You know, at every day you might have dozens of new scientific papers pointing to new directions, showing new algorithms, bringing new ideas. So what I would say is that for sure, if you are in your company and you take some Coursera courses or Udacity courses and so on, this is of course beneficial. But I would say that nothing replaces also the practicability of these. So you need to do different projects. You need to be involved with different groups and talk with different people, not only inside the company, but outside the company. So if you want to become a data scientist, you need to be involved with scientific research groups and involved in competitions maybe, or in data competitions, or involved in practical problems, either inside the company or outside the company while you are learning.
Okay. I think, as you said, there's a new field emerging, and there might not be very well-defined competencies and how to get there.
Yes.
Pretty much at the early stages of such a new discipline. Yeah, but interesting. Thank you very much. If you flip to the final slide, please, Nelson.
Yes.
It was a very, very interesting session, and as we discussed, many questions, a lot of interest, I guess. And yeah, to be continued. I'm sure everybody understands that the way you have shown us what can be done will be done in the future. It might not be at this moment of time for most of the audience today, but yeah, that's a bit of a glimpse of the future, I guess. Yeah, and final words from my end, Institute for Competitive Intelligence, of course, hosting this wonderful webinar. There's some training available for those a bit more down to earth doing competitive market intelligence. Have a look from Paris to Germany, Bad Nauheim. There are some interesting workshops, certificate programs coming up, and our 12th International Competitive Market Intelligence Conference May this time again in Bad Nauheim. By the way, Nelson and myself, we met at one of these wonderful conferences. So this is how to meet interesting people such as Nelson, and then of course take it from there. Thanks a lot, Nelson, and
thank you so much.
Thank you to everybody for attending and enjoy. This very session will be taped, or was taped, and will be made public. So if you need a second time to listen to it, it will be available on our website, as you see at the very top of our slide. Enjoy your day and see you around. Thanks, and bye-bye.
Bye-bye. Thank you.